Alright, folks. Start chapter 5 today. Chapter 5, boop, is going to begin with section 5.2. We skipped over section 5.1 because 5.1 was all graphing calculator skills, solving polynomials using graphing calculators. And since that's not state standard and we don't have a class set of graphing calculators, there is no reason to do that section. There's nothing in there that's worthwhile to us. So we jump directly to 5.2, solving polynomials algebraically. We're going to have to do this across a few days. Today my goal is just to get the front of this piece of paper done, which is, 8 examples. That's the goal. Get just the front of this done. So we'll see how long the lesson takes. Hopefully no more than 3 days. We'll just see. Why does it take so long? Because factoring. That's why. Because factoring. Most of our chapter is going to be devoted to factoring skills. So hopefully you possess said skills. Hopefully factoring is one of those things that you remember from Algebra 1. You go, oh yeah, that's easy. I got this in the bag. That would make life really, really good. We start our solving polynomials algebraically journey with this box that shows us the 3 special cases that we have to know how to factor just by looking at them. We see them, we know the formula, and we plug things in for A and B. We have the difference of 2 squares. That means perfect square minus perfect square, A squared minus B squared. We've seen this one a bunch of times this year. It instantly factors to A plus B times A minus B. These are conjugates. So we use this skill for complex conjugates. We use this skill for irrational conjugates. We've done it at least twice this year already. And you should remember it, I hope, fingers crossed, from Algebra 1. A squared minus B squared, difference of 2 squares, instantly factors A plus B, A minus B. All right. The other 2 special cases that we deal with are the sum and difference of cubes. So A cubed plus B cubed, A cubed minus B cubed. You must know these formulas. You have to recognize perfect cubes. You have to recognize perfect squares. And we practiced our squares and our cubes and things like that before the Christmas break at the end of quarter 2. So here it is, coming right back. Like I said, you're going to need those skills. If you want to factor A cubed plus B cubed, what you do is identify what A and B are. What did I have to cube to get to this? What did I have to cube to get to this? And once you've identified your A and your B, you write A plus B. We'll use parentheses when we square our A minus their product plus, and we'll use parentheses when we square our B. A cubed minus B cubed is nearly an identical formula. The only difference is these 2 symbols will switch places. That's it. The way that I've always memorized it is whatever symbol was between the cubes goes in that first set of parentheses, and then I use the opposite symbol next. The last one's a plus always. So whatever symbol was between the cubes, same symbol goes between A and B, opposite symbol goes there. Whatever symbol is between the 2 cubes, same symbol goes between A and B, opposite symbol gets used next. Every time I go to use one of these formulas, I am going to write the formula down. And if you are in the habit of writing your formula every time you're going to use it, you'll have it memorized, I promise. Could someone please tell me what is conspicuously missing from this box? I have A squared minus B squared, A cubed plus B cubed, A cubed minus B cubed. What should be standing out to you as missing, Daniel? A squared plus B squared. There is no A squared plus B squared for a reason. A squared plus B squared does not ever factor. Now, are there very special versions of it that are of higher powers than 2's that technically are perfect square plus perfect square, that factor? Yes. I mean, there are. Like, a to the 6th plus b to the 6th. Technically, that's perfect square plus perfect square, and it does factor. But the reason why is because a to the 6th plus b to the 6th is actually an a cubed plus b cubed situation. So that's a very, very special version. But anytime you deal with square plus square, it's not going to factor. Just doesn't. Okay? Someone in period 1 wanted to know why. The reason why is because if, let's just pretend this said x squared plus 4. If you took an x squared graph and shifted it up 4, it would point up. And it would look like this. And it would never touch the x-axis. It has no solutions, therefore cannot factor. Well, it has no real solutions, therefore cannot factor. But that's why a squared plus b squared is not going to factor for us. Cool? All right. So let's do some special case factoring. I didn't leave us a whole lot of space, unfortunately, so don't write large. I'm basically reminding myself of the same problem. Don't write large, because in first period I wrote a little large and math had to get squishy to fit. Anytime you are factoring, your first job is always the same. Just look out for greatest common factors. Look out for GCF. That doesn't mean there is always a GCF, but your job is always to look for one. So you're looking at these two numbers here, and you should be able to identify that, yes, there is a GCF. What can I divide both these terms by? 3. Yes. So 3 is my GCF. So we'll undistribute a 3. Oops, sorry. I said 3, so I wrote a power of 3 by accident. And there we go. What we have is 9x squared minus 25, and I happen to recognize that 9x squared is a perfect square, and 25 is a perfect square, and well, there's a minus sign in between them. So that is an a squared minus b squared situation. Which will factor to a plus b times a minus b. I just have to identify what a and b are, and then fill out the formula. What do I have to square to get 9x squared? That's the same question as saying, what is the square root of 9x squared? 3x, yeah, 3x. Remember, whenever you take in the square root of something that has an exponent, you're dividing the exponent by 2, cutting the exponent in half. And what is the square root of 25? Everybody can shout it out. 5, good. So we're ready to fully factor our polynomial. Please don't lose your GCF. It's a really common student mistake. The students will just stop writing the GCF. Don't lose it, okay? There is a 3 on the front. Your a plus your b, and your a minus your b, and you're done. Yay, easy. Care to ask me anything about it before we take it up a little bit in difficulty? Just a hair. Not too bad. All right. Like I said, your first job is to always hunt for a GCF, but this time there isn't one. Okay, it's fine. What we should be noticing is that 16 is a perfect square, and that exponent's even. So 16x to the 4th is a perfect square. 81 is a perfect square, and that exponent is even. So 81y to the 6th is a perfect square. Oh, and there's a minus sign in between them. If there was a plus sign in between them, I wouldn't have been able to do anything, because a squared plus b squared is not going to factor. But since it's a minus sign, we recognize this as an a squared minus b squared situation. Which is going to be a plus b times a minus b. Like I said, I will be writing the formula every time I go to use it. All right, let us figure out what our a and our b are. What is the square root of 16x to the 4th? Well, what's the square root of 16? 4, good. And remember that whenever you take the square root of something with an exponent, you're actually cutting the exponent in half. So if we cut our exponent in half, we're going to get x squared. So our a is 4x squared. For b, what is the square root of 81? 9, good. And again, whenever you're taking the square root of something with an exponent, you're just cutting the exponent in half, and that'll give us y to the third. We have our a and we have our b. This is going to factor to a, 4x squared, plus b, 9y to the third, and then a, 4x squared, minus b, 9y to the third. And right here, we almost had an issue. If this exponent had been even, this would have been a perfect square minus a perfect square. Because 4 is a perfect square and so is 9. That exponent is even. If this exponent had been even, we would add another a squared minus b squared. And we would not have been finished. But it's not a squared minus b squared, so we are finished. Basically what I'm getting at is, it's 100% possible for a perfect square, or excuse me, for a special case to fall out of a special case. And you have not finished until everything that can be factored is factored. We're finished here because that's not special, but darn it if it wasn't close. If this exponent had been an 8 instead of a 6, this would have been a 9y to the fourth, and this would have been a special case. Everybody calm, cool, and collected? In the notes, we will see special cases come out of special cases. Not today, but it will happen. For our next example, I made a boo-boo. I multiplied wrong in my head, so we have to change the example. It's negative 54x to the third, and it was supposed to say minus 16, not minus 24. Now it will achieve the desired result. And this was the one that made me run out of space. Our first job is always look for GCFs. This one has one. What is it? Who could tell me something they have in common? Nobody? You all afraid to talk to me? Max? 8 does go into 16, but it does not go into 54. 8 goes into 56. Okay, so it's not going to be 8. It's 2, almost. This thing that I'm factoring begins with a negative. That tells us that our GCF needs to be negative. So it's actually negative 2. Your GCF is negative 2. Trying to figure out what color I want to write in. When we undistributed negative 2, which is factoring, which is a form of division, we're going to get 27x to the third minus 8. And hopefully it jumps out at you that the numbers 27 and 8 are both perfect cubes. This is an a cubed minus b cubed situation. Oh, yes. Good call. Because that would have changed everything. So it's a cubed plus b cubed. Thank you so much. Formula for a cubed plus b cubed. whatever symbol was between the cubes, we'll use first. Then we use the opposite symbol next. Always end with a plus, like that. We just need to identify our A and our B. So I need to know what the cube root of 27 x to the third is. What's the cube root of 27? It's 3. And whenever you take the cube root of something with an exponent, you just divide the exponent by 3. And 3 divided by 3 is 1. So we get 3x to the first, and we don't have to write to the first power. And B is the cube root of 8. Cube root of 8, you guys can shout it out. 2. A few of you shout it out. Okay. Now we fill out our formula. I need you to be very careful. Right here, your A is more than one thing. When you go to square it, if you don't use parentheses, you're going to have a wrong answer. You must use parentheses. I wish I had one more line of vertical space here, so I got to write kind of short. My A, and then plus B, then my A quantity squared, but that's 3x squared. And then minus a 3x times 2, and plus a 2 squared. So at the very end, again, I do apologize for the lack of vertical space here. Negative 2, 3x plus 2, 3x times 3x. You get 9x squared minus 6x plus 4. And something I didn't mention when I first introduced the special cases, the sum of two cubes and the difference of two cubes, you'll notice that in the formula, we've got a quadratic here. As long as it's a true x squared quadratic, and it doesn't go to a higher power, like to the 4th or the 6th or the 8th or whatever, as long as it goes to an x squared, this quadratic will never factor. And as long as it's an x squared, this quadratic will give you two imaginary solutions or complex solutions every single time. Do you remember how to solve quadratics that don't factor? Remember how we did that? You learned it in Algebra 1. If I asked you to solve this quadratic, remember how? Anybody? Come on, I know somebody remembers how to solve a quadratic that doesn't factor. The quadratic formula. Thank you, Massimo. So yes, you have to know the quadratic formula as well. Next, this one. Always on the lookout for a GCF? There isn't one. Okay, life is good. No GCF. 8 is a perfect cube. That exponent is divisible by 3, so it's a perfect cube. That exponent is divisible by 3, so it's a perfect cube. This is a cubed plus b cubed. Formula for that is a plus b, a squared minus ab, plus b squared. We identify our a and our b, and we will plug them all in. We'll use parentheses, make sure that we do our squaring appropriately. What is the cube root of 8x cubed? You shout it out, guys. Let me hear it. 2x. Good. And then what is the cube root of y to the 6th? Y to the what were you saying? Y to the 3rd. Good. No, wait, no, not y to the 3rd. That's the square root. Y squared. Remember, when you're taking the cube root, you're dividing the exponent by 3. When you're taking the square root, you're dividing the exponent by 2. There we go. So where do we have to watch out? Watch out right here when you're squaring this 2x. Because if you just write 2x squared and you don't use parentheses, that's wrong. Orange. We've got our a plus our b, so 2x plus y squared. And then in here, I'm going to use parentheses around my 2x. And parentheses around my y squared. And since this is going to be an x squared, a true x squared quadratic, this will not factor. But 2x quantity squared, that means 2x times 2x. That's going to give us 4x squared minus 2xy squared. And power to power, you multiply. Finito. Honestly, the hard part is, do you know the formula? That's the hard part. After that, I'd say, did you just recognize that the formula was necessary? Did you see perfect cube plus perfect cube? Okay. (64) happens to be a perfect cube. And 1 is a perfect cube. This is an a squared minus b squared situation. Cubed, I said squared. A cubed minus b cubed situation. Matching symbol goes between a and b. The opposite symbol will be written after a squared. Last symbol is always a plus. We got to figure out what a and b are. What is the cube root of 64 x to the third? 4x. Thank you, Jared. 4x. Cube root of 64 is 4. You see how important it is to know our squares and our cubes? That's why I spent all that time before the Christmas break telling you guys, like, you need to know these numbers, try to have them memorized. And the cube root of 1, that's a freebie. Just 1. So you fill out your formula and you make sure you use parentheses when you're squaring your a term because it has multiple pieces. A minus b, and then our a quantity squared plus a times b plus b squared. (4x squared), that means 4x times 4x, which is going to give us 16x squared. 4x times 1 is just 4x, and 1 squared is 1. And because this is a true x squared quadratic, and that's not a higher power quadratic like a 4th or a 6th or anything like that, it does not factor. So guaranteed that it's finished. So are there remarkably special times when we started with higher exponents where this thing would factor? Yes, there are remarkably special versions. For example, x to the 6th minus 1. X to the 6th minus 1, that's the difference of 2 squares, but it's also the difference of 2 cubes. So because of that, you would end up with something here that's factorable, but that's a very unique case. And example F. I'll go ahead and tell you there is a GCF. What is it this time? Yes, GCF is x. So when we unfactor an x, which is when we undistribute an x, which is factoring an x, which is a form of division, we get y cubed minus 125x to the 6th. And because those exponents are divisible by 3, those are cubes, and 125 is also a cube. Perfect cube minus perfect cube. Matching symbol goes between a and b. Opposite symbol will get written after a squared. Last symbol is always a plus. And there it is. A cubed is y cubed. I hope it's really obvious that our a term is just y. But b, the cube root of 125 x to the 6th. What's the cube root of 125? You guys can shout it out. 5, good. And when you take the cube root of something, you're dividing its exponent by 3. So I'm going to get x squared. Watch out. Your b term has 2 objects. So when you square, if you forget your parentheses, it's going to get you a wrong answer. And on my test, that will be one of the wrong answer choices waiting for you to choose it. Please don't do that. I'll make it worth partial credit, but I'd rather you get whole credit than partial credit. Okay? So watch out for those. Apart from that, very, very, very common student mistake, forgetting to write the GCF. So just make sure it's the first thing you write, always. Don't get lazy. Don't say, oh, I'll just remember to write it at the end, because there's a pretty good chance you won't remember to write it at the end, and you'll forget, and then you'll choose a wrong answer. Please don't do that. Alrighty, our a minus b is going to be y minus 5x squared. Boom. Then we've got our a squared plus our a times our b plus our b quantity squared. GCF. Then we have y squared. I like my variables to be in alphabetical order, so I'm going to say 5x squared y. And 5x squared, quantity squared, means 5x squared times 5x squared, or 25x to the 4th. Ta-da! So we had some GCFs. We had 2a squared minus b squareds, 2a cubed plus b cubed, 2a cubed minus b cubed. Are there any questions I could answer about that stuff? Always on the hunt for GCFs, and know your formulas. Don't try to factor a squared plus b squared. Don't even try. Well, if there are no questions about factoring the 3 types of special cases, then we'll move on to factoring by grouping. We've already covered factoring by grouping this year. We did it back when I showed you why factoring a quadratic works. I don't know if you remember that, but when we had the whole, oh, I don't want to write on that. Let me find a piece of scrap paper. All right, when we were factoring things like this, I taught you how to identify what 2 numbers to split this into, and we did it like this. And then we did factoring by grouping. Do you all remember doing that with me? Okay. Well, that was using factoring by grouping to factor a quadratic. But factoring by grouping is actually right now the only tool you have to factor something when there are more than 3 terms. You see, this quadratic is a trinomial. It has 3 terms. This has 4 terms. There are other things you can do, but for right now, your only option is to factor by grouping and hope it works. Someone in first period, I think it was Samantha, she asked, does the polynomial have to be in standard form? Yes. Always make sure that your polynomials are in standard form before you attempt to factor anything. That means your exponents count down from biggest to smallest to none. These are both in standard form, so you don't have to worry about that, but it was her question and it was a good question, so I want to make sure that I said it. So we are going to artificially clump the first two terms and the last two terms. Please make sure to capture that middle symbol in the second group. Please, please, please. Now we just treat them as two separate things. So we look at our first group and we say, what is the GCF of this first group? 3 is part of it. What's the other part? 3x squared. Good. So we're going to pull a 3x squared. And when we pull a 3x squared, we're undistributing, we're factoring. That is a form of division. It is going to leave us an x minus 4 on the inside. Now we'll look to the second group. And I'll ask you, what is the GCF of that group? 2. All right. Positive 2. Undistributing a 2, which is factoring, which is a form of division, dividing both these things by 2, gets me, x minus 4. This can be considered one object held together with multiplication. This can be considered one object held together with multiplication. So if you look at your two large, and you don't have to draw the braces, but if you look at the two large objects, tell me a factor they have in common. X minus 4. That means I can undistribute an x minus 4 from both objects. Kind of like how you undistributed a 3x squared from both objects, I'm going to undistribute an x minus 4 from both objects. And when I undistribute it from this first set, I'm left with the 3x squared. And when I undistribute it from the second set, I'm left with the plus 2. And that's it. Because 3 is not a perfect square. So this isn't a special case. Also, it's a plus sign. And you will never try to factor an a squared plus b squared. So it's done. You have a question for me?
Yeah.
Yes.
So you have 2x minus 4s.
I do. Okay, so let me go in reverse. Let's take this x minus 4, and let's treat it as a single object that I'm going to distribute. Okay? Going to go in reverse. I want to take this thing, distribute it to here and to here. When I do that, I'm going to have an x minus 4 being multiplied to this 3x squared plus this x minus 4 being distributed to this 2. But the order of multiplication doesn't matter. Which is what we have right there. Yep. So what we did is we treated it like we did this 3x squared, where I divided both terms by a 3x squared and brought it out one time. I'm dividing both terms by an x minus 4 and bringing it out one time. Any other questions on that one? No? Okay. Well then, let's get this last one done for the day and call it there. Anytime you're factoring, you're always on the hunt for a GCF. This one has one. What is it? 2x. Good. We notice that there's an x in all of these things. So let's undistribute our 2 and our x. That's going to get me an x to the third minus a 4x squared minus a 3x plus 12. Yep, cool. All right. The blue polynomial inside the purple parentheses has 4 parts, and the only tool that you have right now for factoring something with 4 parts is grouping. Yes, there are other methods, but for now, grouping is your only option. And please be sure to capture the middle symbol in the second group. Always get it. A very common student mistake is losing their GCF. So in order to combat that, I'm going to make that the very first thing I write on the next line. There. It's out of the way. I won't forget it. I wrote it first. Now, I'll pay attention to the 2 red groups. What is the GCF of this first red group? X squared. Good. When I undistribute that x squared, which is factoring, which is a form of division, is going to leave me with an x minus 4. And what is the GCF of the second red group? Negative 3. Please remember, if you're factoring something that begins with a negative, your GCF is negative. So yes, negative 3 is the GCF here. Undistributing, which is factoring, which is a form of division, negative 3, dividing both these by negative 3, gets me x minus 4. And just like before, again, you don't have to draw the braces. I'm just showing you this one thing and this one thing both have x minus 4 as a factor. So I could undistribute that x minus 4 from both of those red objects. But again, it's a very common student mistake to forget the GCF of the very beginning polynomial. So I'll write that first to make sure I don't forget. Then, I'm going to undistribute an x minus 4 from both red objects. When I take the x minus 4 from this part, it leaves me an x squared. And when I take it from this part, it leaves me a minus 3. And alarms should immediately start going off in our head because we saw x squared minus, and our brain should immediately been saying, I wonder if there's going to be a difference of 2 squares hiding inside my grouping. 3, okay. 3 is not a perfect square. But if that had been a 4 or a 9 or a 16, we wouldn't have been finished because this was almost a squared minus b squared. So can special cases hide out inside our grouping? Yes. Can special cases hide out inside our special cases? Yes. They're going to show up all over the place, and it is our job to be on the lookout for them. We see that x squared minus and immediately start gearing up for special case. Oh, it wasn't one. Okay, good. Stand down. Would you like to ask me anything about factoring special cases or factoring by grouping before we call it a lesson? Always have to do GCF at the beginning. Yes. So if there is a GCF, you must factor it out at the beginning. And that doesn't mean there always is one. And are there ways to do it at the end? Yes. But I usually see students do it the wrong way, and it goofs them up at the end. And I just go like, look, make your life easy. Take it at the beginning. Trust me on that one. Cool? And that includes if at the very, very beginning, your polynomial began with a negative. So if this had began with a negative, even if the GCF was -1, I would say pull it. Okay? All right. Good questions. Good questions. Thanks, nerds.